I'm just going to get started because I just have a few announcements to make. So again, for those of you who haven't heard before, you're getting these cards near the entrance. Hopefully they're still there. There's a QR code that's going to point to a website that will eventually have all of the content from speakers and their example code. And you'll be able to go to that. And so we've come to the penultimate talk in the session, and this is one of these talks that I was happy to see recommended, and I was happy to go in because I will say it's unlike pretty much any talk I've seen at NIWeek, so it was the kind that I was happy to see for something new and different, and hopefully I think very interesting. And so it's going to be Brian, and to tell us a little bit more about Brian for maybe the one or two of you in the room who don't know him already, here's Becky.
Thank you, Darren. So I've had the pleasure of working with Brian for quite a few years now. We actually went to the same college, but unfortunately I'm much older than him. If you don't know Brian Hoover, you probably know him on the forums. He's always on Lava. He's always on the NI forums. He goes by Hoover. See, he's got his avatar right there. So if you've seen that before, you know he's an expert. You know he's done this. And actually, we're pretty lucky here in Michigan. He's part of our user group in Michigan, and he's done a great job. He actually gave a little bit of a subset of this presentation, and he said he's made some changes. So I'm really interested to see what he had to add to it. So it's going to be great. Thanks, Brian.
Okay. All right, yes, thank you for that wonderful introduction there, Becky. So yes, this is a topic that I love, and it's interesting and it's fun. It's something that I want to thank NI at least for giving us this room, because I doubt this type of presentation would happen had we not been given more free reign over this. And I'll get into some of the subject matter why in a minute. But before we go on, there is a quick little disclaimer. So XNodes, you're going to hear me say XNodes a bunch, and I'm sorry if you don't know what XNodes are yet. I'll get into defining them, but you're going to hear me have the disclaimer that mentions XNodes like 5 times before I tell you what they are. But it's kind of important to get this out of the way. XNodes are not a technology that officially NI wants you using outside of the ones that they already have made. They have a bunch already made. They're on the palette. We'll get into some of them. We'll look at the examples. But it's an undocumented function and feature. It is a feature of LabVIEW. It's been a feature of LabVIEW for a while, but it's not something that NI is advertising or probably even condoning developing as a whole. Now, there's certainly people at NI that support us at some level, and we certainly appreciate that. But I think if NI, the corporate group, were to say, have a say, they probably wouldn't want us making our own. Just because of documentation, support, those types of things. But there is online resources, and I got several references towards the end that we can talk about. But for the most part, if you're trying to learn about XNodes, peruse the forums, go onto the communities, and we can have a discussion about what we learned about them. Editing XNodes within the LabVIEW IDE requires a special license from NI. This is not a license that they sell you, but this is a license similar to the ones that they sell you. If you make an application builder, or if you make an application using application builder, you need a special license from NI. You right-click in the project, you say new exe. Without the license, you can't do that. Well, this is kind of like that these features are in LabVIEW, they're just kind of asleep, they're dormant. And until you have that license that unlocks it, you can't make your own XNodes within LabVIEW the same way that NI employees do. They have the features of the IDE. They can go file new XNode. That's not something we can do today without a special license. And by the way, if there's any questions, feel free to interrupt and we'll. XNodes themselves, they do some really cool things, and that's what excites me the most, is that I see them do things that I didn't know was possible. I see them do things that I see NI functions do, and I didn't know I wanted that capability until I found XNodes and found it was possible. Some of the things, like you think about primitives, you think about like a build array, it's resizable, right? You can add things to it. It changes to the type that you wire to it. These are some of the things that we're going to go over, but it's basically the features of what you think of a primitive as, and that's what XNodes give you the ability to do. So that's where I'm really excited, is to do this cool stuff, to make reusable code in the same way that I can reuse NI primitives very easily. So now that I said XNodes 20 times, I probably should give you some kind of definition of it. And we'll reference back to some of these points later. But it's a node on the block diagram. So you're on the block diagram. It's only on the block diagram, not the front panel. And it allows for edit time execution of VIs. This is not runtime. This is not when your VI is running. This is not in an exe. The benefits of XNodes are to the editor, to make your usage of the IDE, to writing code, to make that an easier experience, a more reusable experience. As I mentioned before, they can resemble primitives. They have some resizing abilities, some redrawing abilities, some drag and drop, mouse clicking stuff. They can do stuff that normal sub-VIs that you don't really think of. They are incomplete. They are poorly documented, if you would call documenting them at all. But the technology is stable. NI has been using them since 8.2 era, 8.0 era, and even before that there was the external node, which is kind of the alpha to XNodes. So NI has been investing in this, and they do use it most oftenly on things like FPGA. So it's being used. It's not that the technology isn't safe. It's, in my mind, primarily the effort needed to release this and document this and make this an official thing that I think NI is so resistant on. Oh, and then it's just a library. At the end of the day, an XNode is just XML. You can open it in a text editor, and I'm going to show some examples of that, but it's not a VI file. It's more similar to like a class file or a library. So I want to start showing you some XNodes and making them, but before I do, I want to cover two topics that are official features of LabVIEW, and they're documented, and they're great, and they're good, that XNodes kind of build off of. So quick show of hands, and I hate asking participation when I'm the participant, but how many here has used LabVIEW scripting to make a new VI to do something? Just about at least half. Very good. And then what about X controls? Who has made an X control from scratch? Wow, that's impressive. X controls themselves have some, well, people don't really, they have some issues, and I hope that you don't think XNodes are bad simply because X controls are bad. They share the same common interface, but they're very different. So don't start thinking XNodes are bad. So I'm going to do two real quick examples. Oh, well, real quickly, I mean, everyone knows, well, not everyone. A majority of you know about scripting, so I'm going to try and gloss over this one. But basically, scripting is a way for LabVIEW VIs to write LabVIEW VIs or to edit already existing VIs. So it's code that writes code. It's some very cool stuff. And there's some interesting history about how it came about and how NI created it for themselves and then eventually made it an official feature of LabVIEW. So, yeah, I can. So, real quickly, I'm just going to open up the pre-made scripting example. And it's not all that complicated. There's other ones out there that are crazy, but I just wanted something to reference and talk about and demonstrate for those that have never seen scripting. So here I'm creating a new VI. I'm going to wait a little bit. I'm going to create an add function, wait a little bit. I'm going to get all the terminals on the add. You know, there's two in and one out because you're adding two things. And then I say for all terminals, create a constant if it's an input, or create an indicator if it's an output. And then I wait in between each of them, and then I clean up the block diagram because it's usually a little ugly after some scripting. So when I run, new VI, creates the add, creates the indicator, creates a constant, creates a constant. Oh, and then cleans up the block diagram. So I didn't do anything, I just hit run, and it did that. So creating the add function is not where the benefit of scripting is. The benefit of scripting is usually augmenting already written VIs. You have some templates, you have some whatever, and you want to take it and manipulate it some more. And I know that Becky, her presentation on the project templates, the advanced version of project templates has a lot of scripting involved where you're creating libraries on the fly, you're renaming them, and you're doing whatever. That's using a lot of this stuff, and it's very VI server intensive. XNodes leverage scripting a ton as well. So that's why I want to bring it up and talk about it a little bit. Okay, so back to the presentation. The other technology that I wanted to talk about real quick is the X control. So this is one of my favorite X controls, and I'm going to demo it, but I wanted to at least bring it full screen before that so you can see. But it's an X control is something that sits on the front panel. And remember, this is a legit thing that you can make today in LabVIEW. File new X control is fine. And it's a thing that sits on the front panel that you interact with, and VIs get ran when you interact with it. So it's a little hard to describe, and I'll get into it a bit. But imagine being able to drop something on your block or on your front panel because it's an X control. And a dialog might come up saying, configure how you want this control to look. And you can make some checkboxes and do whatever your settings are, hit OK. And now that control behaves that way. It has the ability to run a VI like a dialog on startup or that type of thing. But it's got other things too, like you can encapsulate a whole bunch of functionality into a single control. So if I have a table that I want to be able to sort when I click the header columns, right? That's a pretty common one, and there's one on Lava that does just that. That's an X control that just has that sorting algorithm all wrapped into the X control. So it's very reusable if it meets your use case. So I'm going to do a real quick X control example using one of my favorite X controls. So here I have a cluster. And then here I have an array, and when I run it, if I have this be false, this thing that looks like a tree will display the array. So you can see that this is, here's the data type, and then it's got 3 elements in it, and they're clusters, and then inside that cluster is a string, and it's got a value of AB, it's got a value of test failed, it's got a value of CD, and it's just basically displaying this in a more flat display. It's still tree, so it's not flat, but it's very useful for displaying a data type that you don't know at runtime. Because I can flip this little switch, and now it's displaying this cluster, right? Instead of displaying an array, it's displaying a cluster. And you can wire anything to it, and it will display it. It's super handy. It colors things, the color of the data type. Great for debugging. I really love it. I got it off of Lava. I forget who made it, but I have the download link, so you can. I think so. Yes. The code is relatively simple. You have, ignore this top part. This is just saying don't update unless there's a value change. So really all you need is my cluster going to a 2 variant, my array going to a 2 variant, and then my Boolean picking which one do I want to display. And everything else, that's it. There's no other code. This is it. And the reason that it works is because everything is wrapped into that one X control. Looking at the project, let me actually close so I can get it. This is the VI I called, and then this is the X control that I called. So if I make a new VI, I can drag it onto my front panel, and bam, just like I described, a little dialog comes up saying how to configure them. And it's got little mouse overs and checkboxes and all that good stuff. Now how did that happen? Well, that happened because the X control has ability VIs. And that's a VI that gets ran on certain events. And in this case, it was on creating a new X control. So in this project, I have the init. And then it's a little bit messy. Well, it's not that bad, I guess. But you come into here, and this is where the dialog is. So this is getting called if settings haven't been configured before, and then this is some version implementation functions. But the point is that this is an ability VI. Now, how does it get designated an ability VI? How does it know to get ran on new creation? Well, in an X control, if you right-click, you can say new, and you can normally do new VI and virtual folder. But there's this other option for new ability. And here it shows all the abilities that the X control can have made for it. So some of them have to be there, like data, that defines the private data to that library, that X control. The state, I don't even remember what that one is. Defines information. Well, what's nice is there is a little description here telling you what they all do. So I'm not going to go through and read them all. But the init one's pretty obvious. It's when you drop it, it runs that VI. Uninit, there is not one made, but I could make it. And then this is a VI that gets ran when you delete or I think it might run on close even. I'm not sure. But it's useful for cleaning up references. So once we make an ability VI, it shows up in the library under our library, and LabVIEW now knows this is a special VI and to handle it a special way. If we look at the xcontrol file itself, right, and this is what I dragged to my front panel to actually make it work. You can right-click it, well, just open it in the text editor and see that it's XML. It's not that crazy. At the beginning, there's all information about the xcontrol, the library itself, what version it is, what icon does it have, a handful of other small things. And then here, we start to see the structure of what we saw in our project. So in the project, we have our top-level controls, then we have a folder for methods, a folder for properties, a folder for tools, and then we have a few things on the root of that library. If I go down towards the bottom, I find those things that are on the root of my library. And init is one of them. Here is this init type, and it's an ability VI, and that tells it, to handle this a very special way, and where do I find it. So the fact that this is just normal XML means you could edit it from here. You could just add lines, you can add code this way. But we don't have to do that. We have this IDE where we can right-click and say new, and this dialog comes up and tells us all kinds of cool stuff. So keep all this in mind because XNodes share a bunch of these common features because they're both under the X interface class. They're both libraries, they're both just plain XML. They both have ability VIs that define how they get ran and what to do when that event happens. But again, notice that this is event-driven, right? This is, I interact with it and stuff happens. The XNode is the same way, it's just that it's on the block diagram. Okay. Let's finally get into a little bit of the meat of this. I hate having to talk about the review, but it's kind of necessary. So, let's say we want to edit some XNodes. What do we got to do? Well, as I mentioned, the best XNode editor, arguably, is the one that's built into LabVIEW. It's the one built into IDE, the one that you need the license for, and NI is not giving it out. So, generally, that's not an option. But there is a handful of INI keys that do make editing XNodes a little bit easier. I know that particularly if you add this to your LabVIEW INI, you get some of that debugging features. The XNode wizard menu is certainly a useful one because it allows you to right-click an XNode and look at some of the ability VIs and the code that it generates. The super secret special, private special stuff, maybe that's too many specials, equals true. That one's not necessarily required. And do be cautious when you have it enabled because it will enable private methods in your property nodes and bulk nodes, and even a handful of other things that are not officially supported outside of NI, and they just may have strange behavior. They might not be fully documented. It's a lot of tools that NI is just not certain how they want to do it, or not ready to release it for one reason or another. So if we can't use the built-in LabVIEW IDE to edit XNodes, what are our other options? And this is the XNode editor that is the unofficial editor. This sort of gets around the whole NI license bit, but we can do that because it's just an XML file. There's nothing special about it. It's just like an xcontrol. You could open it in plain text and you'd be able to see it as it is. It does have a couple of other features that make it a little bit better than writing in Notepad because it'll list the abilities that you have an option to create and give you the description. Just like an xcontrol, when you say new ability and that dialog comes up, this is kind of a similar way of doing that. So, real quick demo of that. And I'm actually going to make make a new XNode using the XNode editor from scratch. Yeah, question?
Where, if the XNode editor is not available, where do you get it?
The XNode editor is a custom written tool to make XNodes. Okay? The thing that's not available is in LabVIEW I can't go file new XNode. Or I can, but don't talk about that. Need to demo these. I need to dry run these before I present.
Where do you get the XNode editor?
It is not available. It is something that NI has for internal use.
No, this is
Oh, this one. Oh, this is on Lava. Yeah, so this just writes the XML. So let's make a new one. So I just run it and say new XNode, and I need to pick a place to save it. And it's going to go on my desktop because that's where all my junk goes. Okay, so now once it's created, it created this state control. And this is the private data that exists, and it has to be there for every XNode, but it's got to be there for every XControl too, I suppose. But it doesn't matter what the data type is in it because I'm not going to actually use it. And I'll show you why. So in this dropdown is all the different abilities, and this is a lot more than the X control. And part of it is because there's duplicates. You know, NI, I assume, is doing this for legacy support, like they probably do this to build menu in certain ones and they don't want to necessarily take it away. Or a lot of these are just changing slightly how it works. But there's certainly more functions than the X control, and there's more with every version of LabVIEW. So NI is definitely investing in XNode technologies and at least continuing it internally. So I'm going to make an ability VI, and I'm going to make the copy. And notice when you pick it, the text here fills in just like the X control would in our normal IDE. And it tells you how it works. And all this information, all this description is actually pulled from LabVIEW resource files. So hopefully when there's new versions of LabVIEW, this tool still works and still just scales. That is, unless NI hides it in a different place in the resource files or things change unexpectedly. So I'm going to create the copy function, and basically what the copy is when a new copy is created. So if I use control and I drag it, or if I drag it onto my block diagram as a new, or if I do a select a VI and I pick it, this is the XNode ability that gets ran. I'm going to say, let's create that ability, and I can double click it and open it, and here it is. And all it does is makes the interface and the connector pane and everything the way it should be. Right? This is kind of like the template, and then you write your code to do stuff. And this is where the documentation fails, right? Or ends. Because this reply, what can I put in there? You know, what does that do? And there's no answer, you know, outside of NI. So usually what we do is we look at already existing XNodes and see what functions they use and see what options they have and how they behave. But to be fair, that could change in the next version of LabVIEW. That's something that NI, they haven't released this, so it's their prerogative if they want to say that this behaves slightly differently. So that's something to be cautious of. So what I'm going to actually do is I'm going to make an XNode that does something when a new copy of it is created. And now the simplest thing I could come up with real quickly was to open a URL. And that might not seem like that useful, but I'm going to say open URL in the default browser. And I'm going to say go to LabVIEW.org. And in the reply, I'm actually going to say transaction, or failed transaction. And what that's going to do is tell the XNode, don't do anything else, you failed. Something went wrong in our creation, and we're done. That's all we're going to do. And you'll see why I want to do this, but so now I have this, I'm closing the XNode, let's close this, oh, this is here. Okay. And so now, from that file on my desktop, which was, if I drag the XNode to my block diagram, up opens my browser, and I go to LabVIEW.org. Now, oh no, that's fine. But it didn't actually create anything, because I did that transaction fail. But maybe that's what I wanted it to do. If you look on your palette under the add-ons, it's not on my screen. Is this oh yeah, that'll probably do it, right? I don't know where add-ons is if I do it this way. Yeah, I know, but search partially defeats the what I want to demonstrate. Oh, no. Oh, there we go. That'll work. Okay. I want to see all. Add-ons. Whew, that took way too long. So under add-ons, we see this Find Add-ons. And when I click it, it takes me to LabVIEW Tools Network, which is really cool because if I'm on my palette just perusing and I was looking under my add-ons, I would see that link and I might click it to see where does this take me, what can I do? And it's you know, it's not the conventional place to find documentation or to have functions happen, but you could do something with this, like with your Tools Network items, right? You could have that be a link to your personal web page, or you could have that be a link to, here's some other tools that I make, you know, that are on your palette. Another one I use is I have some build templates, and so under my reuse library, is it not going to show up as well? Resolution. Templates, and I have a show application builder tools. When I click it, it opens a folder. And this is where my application builder tools are installed. So I have a package that, when it gets installed, not only does it add it to the palette, it adds these files into my templates that I can then find. So it's not always the conventional place you find documentation, but it's an alternative. And I think it's a somewhat natural way to find stuff, because I'm going to be on the palette looking at your new API anyway, see what functions I have. But this is just one example of where an XNode can do something you probably didn't know you had the ability to do. I think that's good. Okay. So now the next thing is, now that we saw how the XNode editor works, let's look at some XNodes that are already made. We want to see some more functionality, and we don't have the time here to demonstrate all of them using all the abilities. I wanted to show you a copy because that's a pretty easy one. But let's look at some that are built into LabVIEW today that you may not have known. So the max regular expression, yeah, that's what that means. Yep, that's actually built off of an XNode. Behind the scenes, it's just calling a sub-VI that then does some slightly different things depending on how you resize that function. It is not a primitive like you may think it is based on its code. There's a lot of FPGA stuff that is XNodes, and one of them that isn't just for FPGA is the parts of the time structure. And then my favorite, which is one I'm going to show a little bit of, is that error ring, because it's underutilized and is really super useful for doing errors, which isn't that big of a deal most of the time, but when it's convenient, I love it. So if we drop down, so let's look at the math regular expression. Here's this function, and I can resize it, right? That's cool. I can add these strings, and I can add the things that are associated with me doing a regular expression. But if you have those I&I keys enabled, you can right-click, and this little menu for XNode Wizard shows up. And here's all these ability VIs that we were talking about. You know, making the image for the sub-VI, or under the XNode, the help for it, what do I do, how do I generate code, and then here is the actual generated code. So it's just going to be a sub-VI at the end of the day. So when I click that, it's going to be generating the code that's associated with it. And as I mentioned before, scripting code is generally ugly. So I'm going to remove this and then clean up the block diagram. And we can see what this actually does and how it works. And if we are resizing, I'm assuming this is probably just going to resize and add another indicator. So let me actually, yeah, that's good. So if I make it larger, generate code. It's still that same sub-VI, but again, the scripting behind the scenes is going to be resizing that index array and then adding those indicators. Another fun one is that error ring. I demoed it in my last time that I presented this, but I love it so much that I'm going to mention it again. Here's an error ring, and when you click on it, notice this dialog comes up, and that's not like a normal sub-VI for sure. But you click this, and you can have it be an error, and here's a handful of categories that are kind of fun to go through. But there's no search, so it's kind of hard to use unless you know the error code or you look it up. But at the very bottom, they have custom error codes too. So I'm going to put in a custom error code, 43, because I know everyone hates that. And then I can put in a description. So for those that don't know, error 43 is the user canceled. So I can say, I don't know why you canceled, but I was doing, and then here I can put in like %s, which will be an input. So now, not only is this a error constant, I can put an indicator, hit run, oh, but I need to have this wired. It was init. So now when I run, this error is created, it's error 43, and the description has all that information in it, and even the text that I put in. So this can have multiple inputs. You put in %d, you put in %f, you put in whatever you like, and it gets larger, and as those inputs are added. This is, again, just an XNode. I can right-click it, and it's surprisingly simple. It's just this. You know, I could have done that myself, but it sure is useful when I need to update it and change it, that I can just be here and click a change or add an input or change it. So that's where the reusability comes in. I could have done this, but it's, yeah, I think readability is another important one for that. So as for demos of built-in XNodes, that's about it. And the reason is because the other ones are password protected and locked down. And I can't show you the functions that do the draw or do the generation. So I'm going to move on to some public examples that are more open, so we can look at some of the functions and look at some of the features that they have as well. So let's look at truth table. So I have the truth table XNode that I just dragged onto my block diagram. And you'll notice that, first of all, it's big. It's not just 32 by 32 pixels. It's as big as I want it to be. I can draw this, and it's huge, or I can draw it into small. It takes 2 inputs, and you get 1 output. It's just a truth table of what do I do if one is true or one is false, and the other one is false, and the other one is true. So in this case, you can see if X is true and Y is true, then my output is true. So when I hit those two and I hit run, sure enough it is. But I can also click this and change it. So now I say, well, if they're true and true, that's going to be false. So now when I run it, it's false. I can click this and change what I want that truth table to be defined as. Thank you. This also supports changing data types. So here I can give it an array of inputs, and now all of a sudden it says I need to be an array of outputs. So I now have that array of outputs. Let's look at the generated code, because again, it's surprisingly simple. Why? Oh, this is yours? Thank him, ladies and gentlemen. Yes, so surprisingly simple. It's just this constant that as you click on it, it changes the Boolean constant on this block diagram, which is again surprisingly simple. But the interaction of it is where the benefit is. You can look at the other abilities because it's not locked down for things like the image. How does the image get drawn? There's a sub-VI, and we can drill into here, and we can actually look at the pieces. But more or less what's happening is we're drawing what is going to be seen based on our values. So here is our 2D array of what that truth table should be defined as. And then here we're creating the image, and then we're shifting the image, and then we're building it with all the other images. And the end result is us drawing this exact picture. And you can do that based on, like a picture constant can be a starting point, and then you can tweak that constant based on other things. Or you can read the image for a sub-VI, and then that can be your starting point. So now that I'm talking about picture constants on the block diagram, I'd like to demonstrate the picture constant XNode. So, picture constant, this is also on the forums, all the links will be available. If I drag this to my block diagram, it will look just like a picture constant, a 2D picture constant. But it's not. It's actually an XNode at this point. And what the XNode allows you to do is to drag a picture onto it and have it turn into that picture. So you drag a picture file and it will turn into that. So here I have my Windows Explorer, I have a picture. And if I drag it and I drop it, it turns into that picture. And so at this point, this is still an XNode. I can drag other images to it and it will turn into that picture. But I can also right-click and say, turn it into a constant. Well now, what's different from this versus what LabVIEW does? I can make this an indicator. And now that picture's there. Or I can edit that picture. Or I can save it. Or I can do whatever. This is an instance of that picture embedded in my code that I can then use. It's not something you couldn't have done yourself. You absolutely could have. But the convenience of it is there, where you just drag it on, bam, there it is. And then this is even safer because I can right-click and turn it into an XNode. I'm sorry, turn it into a constant from an XNode. And you can see that it is now just truly a constant. I don't have that XNode menu. So it's like a helper function. It's an IDE helper that makes my life a little bit easier. Sure, yeah, go ahead. What do you got to say?
Well, I was happy to see you demo 2 of my XNodes that I posted to but I'll say, for what I liked about the truth table XNode that I posted was that there was a very specific idea posted to the idea exchange. And a lot of times with these new ideas, the initial reaction is always, why would you want to do that? I don't think it's a good idea. And you sort of feel like oh, I think it is, if only I could try it, you'd see you could like it. But for a lot of these things, you wouldn't think that that's a capability that you have to try to prototype that thing. So somebody suggested the truth table node. I looked at it and said, that could be kind of interesting. Let's see what it feels like. Was able to mock that up and then quickly see, like, oh yeah, that could actually be pretty cool in certain situations. It's a self-documented, non-traditional function. So it's a role that you have sometimes when you want to try something before you buy it, or if you want to have a better time convincing people that something new that you didn't think you could do is actually useful. And so that's, the role, certainly of a lot of the ones I've created have been that exact way. So I'm happy to see that.
You're welcome. Let me talk about some of mine now that yours are so awesome. All right, so I got a bunch of them, and I demoed like 4 or 5 the last time I presented this, and that was too many. This isn't Brian promoting himself; it's Brian promoting XNodes. So I'm going to show you. I'm just going to show you one of mine, and it's a pretty useful one because again, it demonstrates something that you don't see in sub-VI functionality. I'm going to show you a circular buffer, and for some reason I think it opened it fine this time. Yes, it did. Okay. So it doesn't quite fit. Close enough though. Actually, this isn't all that important. I just need the stop button. Okay. So this is a circular buffer. I'm going to hit run, and it's going to start creating a buffer that is size 5,000, and it keeps growing and growing and growing, and the y-axis keeps going up to show you that there's new data. But the x-axis is now locked at 5,000 items because it doesn't, because the buffer is full. You're putting something new in the front, and the stuff on the end is falling off. I can change the buffer size, and now it's smaller. And if I increase it, it continues from the buffer that it currently has, and then grows up to that limit. This is pretty handy, and you'll find example code for it on NI's forums. But how I did it was with XNodes. Now the reason I used XNodes is because I can do stuff with it that does type adaptation. I can do stuff where the type changes based on what I wired to it in its first function. So here I have an init where I'm telling it, you need to initialize a double. And that's just like the obtain queue, right? If I do obtain any of these really, I have to tell it the data type, and then when I do something like a DQ or an NQ, that data type will change to whatever it is that I wired from my initial creation. Well, here it's the same thing. I'm telling it, you're going to be a double. I'm going to create an array, well, a buffer of double data type, and then here I'm going to do a write. The write will only accept a scalar or an array of that data type. So in this case, I'm adding 100 elements to that buffer. But I could be adding just one. This will accept a scalar as well. But it will only accept a double. It won't accept a cluster or an array or of strings or other things. And the read is also a 1D array. It returns the entire buffer because these options can do subsets, but it's just a. So I can change this, and I'm going to just change it quickly to something like a U32. And then notice that my icon's actually the icon color change. This is now U32, the wiring is a U32, and the indicator is a U32. But we can get crazy, and this can be something completely arbitrary. So I'm going to have a cluster with an array of string with a false constant in it. That's going to be my data type. Now it's going to break a bunch of things, because I'm trying to do stuff like add to a cluster. And I'm trying to put an indicator on this that is not appropriate. But the icon here, the color changed, and when I do a write, notice, I can do a constant. I can say create constant, and all of a sudden it knows the data type that I'm allowed to write. And if I create an indicator, it knows the type of indicator that I plan on using. So this is a type adaptation that goes, across multiple functions. I can also have it just on a single function where the input changes based on what you wired to me. And my outputs can change based on what you wired to me. But I really like this concept because assuming you have this reference wire that goes along with everything, all the functions down the line will change. So if this is a type def, when I update that type def, all the functions down the line change. Your question?
Yeah, so the difference between this and polymorphic PI is that you don't have to rewrite all the permutations.
Right. So instead of pre-writing every permutation, like a polymorphic PI, you have the scripting code look at the data type and then generate the code based on what that data type was. And so in this case, it's actually quite simple. We can look at the generated code real quick. And all I did was I created, I initialized, well, this gives me the default data of that data type. and I put it into this DVR that goes on. So when you change that input, all it does is change this data type. And since you can wire anything to a cluster, this accepts any data type. So there's nothing that will break this. Okay, so so that's one of mine. There's several others. They're all going to be available online, but that's the idea. So real quick summary of some of the features that we're talking about. We can have features like detecting single mouse clicks, right? Like we saw on the error constant, the error ring. We can detect clicking, like we saw on the truth table, double clicking. You can invoke code to get written when you wire stuff to terminals. The terminals can change on the fly. We saw dragging and dropping from Explorer. You can do also other dragging and dropping from within the IDE. And it can create very highly reusable code. These are just some of the features that XNodes have. But the thing that I really want to talk about, and I'm hoping I have enough time for it, is the new slides. So I presented this a few months ago, and for those that came to this presentation, I hope you anticipated me not just doing that same presentation. I did some more research and got some new topics to talk about. And one of them is VI macros. So originally posted publicly on the Idea Exchange, Jeff K. Was answering a question where someone said, hey, I want to be able to delay data type, or data on a wire. The most common thing that people want is the function here where you can put it on a error wire and say wait just some amount of time. It's kind of, sequential control. But what he posted adapted to any data type. It could be any wire could be delayed. It wasn't just this error. And so once you looked into it, you realized that a VI macro is just an XNode. It's a very special XNode that NI already has written, but it's still just an XNode. You can still look at parts of the generated code and see how it works. Being an NI1 was locked down last night. But to make a VI macro, you just take the VI and you rename it VIM. So let me demonstrate the one that Jeff posted. Oh, I want to do it in 2016. So in 2016, I have a macro, and I think it's stall data flow. There we go. So I drag it over here, and I drop it, and I can double click it and open it. It's just, at this point, it appears like a sub-VI. Right? And I can see all we do is we have a sequence structure, we have an in, we have an out, we have a delay, and then the output is this tape. So all I did was drag the VIM, but now I can do something like if I have an array of string, it changes to that array of string, and the delay still works the same way. I can set the delay 1 second. But I can use this somewhere else and say array of, how about error, which is a little weird, but you can do that, and it'll change to whatever that is. Now there is a few caveats like all inputs change to everything. So my delay, like right now is 1,000. I can make my delay an array of string. And it's clearly not happy. So you can click the broken error and it just says, hey, your XNode is broken. And even double clicking it doesn't help too much because this isn't the generated code. This is a preview of the VI you initially wrote. You have to right click, have this menu, and check out the generated code, where you'll see, oh, you tried to wire that and that doesn't work. Most of the time you don't have this problem, especially with a function like this. It's pretty clear what inputs can be what. But if you put in some decent amount of help, like some dummy text, then it will pop up here and at least give you some insight on what you can and can't do. So that is the VI macro as of 2015 and older. But there's a new thing I want to talk about in 2016. And that is that there's a new structure that is not necessarily public, but it's in the Mac evaluation version of LabVIEW 2016, but not the Windows version. But you can copy files and it seems to work. I downloaded it for this demo so I can try it out. But the new structure behaves similarly to a disabled diagram. And I can show you that it looks very similar to a disabled diagram. This is actually it right here, and I'll demo it. But what it basically does is it looks through every case and finds a case that has no broken wires, and will use that case. So it is smart enough to say, well, which one works, and which is the first one that works, and that's the one that I'm going to use. So let's come up with a good example in 15 minutes. Let's say I have an array of something, and I want to filter it. So if I have an array of, say, string, and I want to remove all strings, so this is my input array filter output array. How would I do this? You know, there's certainly, oh, I didn't make that an indicator, did I? There's certainly a bunch of ways to do it, but I think the most efficient is, well, you can do it on an array, but for this demonstration, I'm going to use for loop and go through each element individually, and then have an equals, and then a conditional on the output. So I want to say not, and yes, I could use a not equal, but I'm going to want that for later. So if I have an array of AB, and I run it, it's now removed, but if I filter something else, it's not removed. This is relatively common where you'll say, usually like empty, right? You'll say, I want to remove all, I want to remove all empty cells. So it did, here, remove all empty cells. And so I can save this as a VI macro, just as filter array vim.vim. Oh, I think it still puts a VI at the end of that. Oops. Mine. Yeah, it did. Oh, is that what it would have worked? Okay. So now, let's close this. Let's cross our fingers a bit. We drag and drop it. And here's this filter that has my inputs and my outputs, but it can now change and do something like an array of doubles and a double. And now it's not broken because everything's all happy. That's great, but has anyone ever used this type of function trying to filter out not numbers? Because if you use a equal comparison on not numbers, anything, well, nothing is equal to not a number. I think that's the way I want to say it. So let me open this up again, and we're going to say, what if these were those doubles? Oops, that's where I controlled. Okay, so, what is this? Did it break for me? No, that's good. Okay, so if I have this say, remove not a number, and I give it not a number, when I run, that not a number is still there. And the reason is because nothing is equal to not a number, even not a number. So for doubles, we can do something a little bit specific. Under the comparison palette, there is this not a number. So I can say, is the thing I'm trying to filter not a numbers? And is the thing I was just given not a number? If so, then, crap. I gotta remember the logic. So this is true, so I want to invert and say and. Yeah, there we go. Okay. So now when I run, it filters not a number. But if this is something else, then it's still there. But if I put a 6 in there, it's now gone. Okay. So now I'm saying two things essentially. If they're both just normal numbers and they're equal, get rid of it. If they're both not a numbers, also get rid of that. So we're going to save this, close it, put this back to being a Vim. But now we broke something, didn't we? Because if I put an array of string in there, even if I give it the right inputs, when I look at its generated code, it's going to be broken. Because this function doesn't accept any strings. So what do? Well, I could make two Vims, or I could use the handy-dandy new structure that I don't think has an official name. What was it called? Type-enabled type enabled structure, I think is what it's officially being called. Well, no, it's not officially being called anything yet. But here is the structure. Oh, I already wrote it. Here's the one I prepared earlier. Actually, I'm just going to use that, if you don't mind. If you don't mind me showing my laziness. So here is this filter array that I made earlier, and I'm going to give it an array of strings. And in another case, I'm going to give it an array of doubles. And in the string case, let's look at its generated code. We can see that this case is disabled. You know, it's not picked because it's the one that's got the error stuff, or the not a number stuff. But in the other case, it was the normal filter that we first created. Now if we look at the double one, though, that one is the one that is enabled, and the disabled one is the string. Now this one is not broken, but it will pick the first non-broken. So in this case, it's case 0 that has the special stuff for handling non-numbers. So the point of this, there's a couple of things. First of all, we got to look at the fact that inputs can change to whatever you wire to them. And within that VI, if all the primitives and nodes that are in there accept those data types, it'll just run and be great and be happy. If you wire something to it that it doesn't like, it'll look like it's okay. You know, it'll wire, but it'll be broken inside, and that's when you'll have to go in and look. Question?
Yeah, how do you know the order? Like, how do you set, okay, this is case 0, this is case 1? Because it's dynamic, it's enabled, so...
It's literally the first or the second. So like here, this is case 0, this is case 1. So it will evaluate them from first case to last. And the first one it finds not broken is the one it uses. I got... It will be, well, first of all, I think I can post it online because it's part of LabVIEW. It's shipped with LabVIEW 2016 on the Mac. It is not shipped with LabVIEW 2016 on Windows. So I downloaded the evaluation version of Mac and found this VI and then found the structure, and that's what it is. It doesn't show up on your palette at all.
So you use it, you have to drag it from the
As far as I know, yes. I don't know any other way of making it yet. I've had like 2 days to use it, play with it, and put it in my presentation, so I don't know all the ins and outs. But I do know that. So yes, oh yes.
I would have thought there'd be an ability in VI to like create a broken wire.
Okay, so there absolutely is. Keep in mind, this is a VI macro, not an XNode. For XNodes, you have so much control, right? I can literally tell it to do whatever I want. I can say, and you saw a little bit of that when I tried to wire data type to an XNode that it didn't want. It would break, right? And that's written into that XNode. It would say what abilities it can do and what to do if you don't see the ones that you want. I think NI is thinking XNodes have a high barrier to entry. There's a lot involved. I mean, there's certainly not a real editor. There's a lot of abilities. It's not documented. And the majority of an XNode's reusability is in type adaptation. It's in trying to be a generic or trying to be a polymorphic. So I believe that's why they came up with VI macros, because it's super simple to make. I just made a very useful function here in just a few minutes. But I think the power of XNodes is truly in an XNode. You know, because you can do things like resizing, right? That's something you can't do with a VI macro. It's just a static sub-VI, and the VI is a template that you provide. I think that's about it. Yeah, so... Yep, I think that's it. So, questions? Anything else? Any thoughts? Yes?
Are you dragging the XNodes on the two-lot diagrams?
Yes. Yes.
Put them into something.
You absolutely can. I showed a couple where they were there, where it was like the find tools. That was on the palette. Yep. VIPM doesn't allow you to easily add them to like a package if you're making it, but there's workarounds. You can custom add it to your palette.
Hey, you showed the XNode where you were managing the buffer.
Yeah, circular buffer.
Can you imagine rewriting that now as the other?
No. It might be possible, yeah. The way I wrote it was, as you saw, using DVR, and so, yeah, maybe it's possible. I haven't tried. Again, 2 days.
do you ship XNodes in your code?
So, hold on. One of these told me all my super secret slides that had questions like that. There we go. Okay, what about when you build an exe? All the scripting code is not there, right? The thing that is there is the generated code that it actually has. So it's, I can't say safe because I don't work for NI, but there are XNodes in your exes today probably that you don't even know. Those are officially NI supported ones, absolutely. The stability of an XNode, in my opinion, or the instability of an XNode, in my opinion, comes from when you're writing it. You know, I can write scripting code right now that crashes LabVIEW. You know, I do weird things with references. I cast it ways I shouldn't. I try and generate an event on something that's not an event. That can happen. And the majority of XNode crashes, that's what it is. The problem is the rules aren't very well defined or documented, so it's easier to screw up and crash LabVIEW. But once you have an XNode that's relatively stable and you know, you play around with it and it seems to be good, I don't see issues. But I can't be the definitive source on it. Yes? I wanted to add that to my slides as a secret question, but I forgot. There is issues with XNodes and classes. I don't know, I've only had 2 days. NI knows this, and the channel wires were actually XNodes when they were first beta tested in 2015, but they had problems with classes. And in my testing, it's a weird circular dependency where I had things like you would open the XNode and the class would be locked because it's loaded. But then if you loaded the class, the XNode was locked because it was loaded. And so there was no easy way to edit. And I don't know if that's the issue they ran into, but I bet that was one of the issues. Yeah. Any other questions? I do have a couple other secret ones I'm hoping to hit.
So as you reverse engineer these XNodes and you figure out what you put in the reply here.
Yeah.
Do you guys document that anywhere? Does the XNode editor have any documents? Like here's the ones that we found, so we don't have to go through.
You want to start that, Chris? There's community, on Lava there's discussions, there's no aggregate list. Partially it's just ones that I've seen, you know, to see what you do. Because like there are some replies like when I change, like when I wire something, I can say, you need to go regenerate your icon, right? You saw that the icon changed color when it's got a different data type. In the reply, there is one that is like update image, and that will call the regenerate my image. You wouldn't know that if you hadn't seen someone use the update image. Take 4 minutes on my watch. Anyone else? Yep.
Are the slides available?
Absolutely. The demo code's available, the slides will be available.
QR code.
Right, yeah, definitely. Yeah.
Yep. Just do it.
Yeah, I should see if it works. I've had code where I determine whether or not a terminal is allowed, or like a data type is allowed to be wired, whether or not it breaks the generated code. It might be generic enough to work for the VIM, so that you can't, you know, once you try to wire the array of strings to the time, it recognizes broken code and then gives you the feedback.
If you have an XNode.
But you'd have to put that generic code in
Yes.
the XNode
And
behind.
I started working on that before I found this structure, or before I learned about it, where I wanted to make code that generated an XNode from a template. Right, so that was using scripting to generate code that generates scripting that generates a VI. I didn't get very far, and I've abandoned it now that I see the structure, which goes 90% of the way there.
And in my own experience, nothing that you run into using an XNode is any more annoying or frustrating than using an X control. And in fact, often much less, in my own opinions.
Yes? I don't know what I can say. I do not know NI's plan for code that generates code when you interact with it, or code that generates code in general. I don't know. I wouldn't know the answer to that. NI does.
We would hope that the functionality is there. How they achieve that type of functionality, I don't know. I couldn't say if I didn't.
Right. I mean, code that generates code, that needs to be there at some level. I would put up a pretty big stake if NI doesn't have something that is either scripting or resembles scripting. But I can't say. Yes?
I think this is extremely powerful tool, but the same way it's extremely powerful tool to create bugs. And as a result, what is needed before start to use it, it is some kind of good programming practice, specifically for XNode. Because even your example, this array of not a number, it is a potential bug, because if I create such kind of structure, and simply there are too many data types, I simply forget about doubles. And after a year, I reuse this node for double, and don't see any error from beginning. After some time, I meet the problem, and I search the bug, and I spend enormous time. This is why it's extremely important to have good programming practice for this kind of programming.
No, that's a great point. Absolutely, it is. You know, you can't think of literally every data type that will ever be wired to this terminal. You're going to have to think in groups. You're going to say, how does this handle if it's a string, or if it's a cluster of random stuff, or an array of random stuff? But no, that's a very good point, that you might write some code and someone use it in a way that doesn't break it, but does something you didn't anticipate. Yeah, unit test, I guess.
One more way in the back.
All right, last one.
And I may just not have missed it, but is the Vim itself almost considered a sub-VI? So like in that example, you found the bug. You had to go back in, make the edit, and then you kind of had to start all over. So is there...
So when you drop a VIM on your block diagram and you double-click it, it shows you the VI as if it were a normal VI. It doesn't have the controls replaced with the ones that you wired in that instance. For that, you have to right-click and say, XNode, show me the generated code, and then it will show you that exact instance. And that's when I showed showing the string or the double. So, what was the question?
Well, so like you'd used it, right? You wrote it, it's in your app, and you went, oh crap, not a number doesn't work.
Oh, so you're saying, how do you now edit it, because it's in your VI like that? I don't know. I'm hoping you can, I don't know.
Okay.
2 days.
Yeah.
Yeah, it's new. It's even different.
It's very new.
The front panel is kind of there. It's like a different flavor, even from XNodes, that I think will take a little while to get our heads wrapped around.
Okay.
Yeah, I mean, I think officially that'll be it. People feel free to come up and